Hi. I changed my title a little bit because I didn't have a cachet like tidy text or use the word machine learning. So I call it untidy text analysis. And it's really about a package I developed called Quantita. So I'm going to tell you a little bit about what the package does and its capabilities. This is not a tutorial, it's just an overview. Oh, what's this? How many of you have $300 in Bitcoins? No, I'm just kidding. It's late in the session. I figured, you know, it's the afternoon, it's after lunch. Wake up. Oh. So how many of you have used the TM package for R? Okay. How many of you have used NLTK for Python? Okay. So I used to use NLTK for Python, didn't like it. It was okay, but when I had to do the analysis, I was just taking stuff and dumping it into R. And then I looked around and tried to figure out what I could do text mining in R using, and this was about 5 years ago, and TM was really all the stuff that you've heard about today. These are all innovations that have happened in the last few years. So I decided to write yet another text analysis package. So why would I do this? Well, the project started about 4 years ago. It was funded by the European Research Commission, which hopefully in the United Kingdom, where I work, we'll still have access to in a few years. The idea is not really to compete with other R packages, but to basically give Python users a reason not to use NLTK, and also to give to show computer scientists that you can do respectable NLP using R. So it provides a set of basic level complete functionality for NLP, but it also gives you a lot of higher level tools. So the idea is that you don't have to be an expert R programmer to do manipulations. You don't have to know anything about the tidyverse, and you only need to know about basic R functionality, and you'll be able to get real powerful analytic results using Quantita. And we also wanted to very much follow good practice, and this for us meant being R-like, first of all, to not make, so if you learn to speak R, you would learn to speak how the package works. We wanted it to be flexible, consistent, and fast. We wanted it to be interoperable with other packages, so there's no reason you couldn't use the other packages you've heard about. In fact, I've contributed some code or encouraged them to make sure that these, their objects and our objects can interoperate. We also wanted to encourage a reproducible and transparent workflow. So I'm an academic, I'm a social scientist. I publish results using analytic tools. I wanted this to be something that would be fully reproducible and open. That's extremely important in social science to ensure that we can trust the results that we call science. Here's a demonstration of what I mean by this being R-like, for example. So we have a corpus object, and you use a summary command. The summary command gives you information about the text in there, but it also gives you information about the variables that are associated with the documents. There are commands for getting the number of documents. It's called inDoc. Why? Because for whatever idiomatic reason, R calls these things in row, in call. So we chose the analog would be inDoc. In feature tells us how many features are in a document feature matrix. If you want to tokenize a text, the structure of the tokenized text is basically a specially classed list. It's actually a very efficient version because it's been hashed, but it's just like a list. There are checking methods, like you can query, is this object a Quantita tokens object? It's is.tokens. Not that I would have chosen that necessarily if I were starting over, but that's how R works, right? So we're learning, you know, learning R is like learning English. You can speak a few phrases very quickly, but learning how to speak it well is a masterclass in idiom. You can coerce objects you can coerce all the Quantita objects to their basic R equivalent, like as character will just give you a list of the character objects that are part of the tokens. So when I mention that it's flexible, we want the object types to work very well together in an integrated way. It's very easy to coerce Quantita objects into standard R objects, and all of the functions can use Magritte type piping. We wanted it to be consistent. So the grammar is very consistent. Even though we try to make conformity for some things with the R grammar, which is inconsistent, we chose an anally retentive naming scheme. Like all the data objects start with data underscore. The next word between underscores is the class of the object, and the word after that is descriptive. So we have things like data underscore corpus underscore inaugural, but with this finger here, you never have to type the whole thing out. You just hit tab, right, and it auto-completes. And this is common, that we have a very common approach across functions. I mentioned that it's fast. So there are a lot of the core workhorse functions are written in C++. We use the stringy package for all string handling. Without the stringy package, I don't think we could really do text analysis in R, but stringy is absolutely awesome. We use sparse matrix operations through the matrix package, and we use data table in many of the functions internally to exploit its speed and power. When I mentioned compatibility with other packages, so something Taylor didn't mention was that we had a workshop earlier this year where we talked about an interchange format for core objects in text. The idea is that Quantita will behave very well with those. It's also easy to coerce Quantita classes into standard objects. You can construct a Quantita corpus from other packages objects, such as the TM's corpus object or the one in TidyText. There are import and export methods in TidyText if you prefer to use that for part or all of your workflow. And most importantly, when you construct a document term matrix, or what we call a document feature matrix, we wanted to make sure that you could export or convert that into all the various weirdo formats that common text analytic, high-level text analytic packages require. For example, the LDA package, or TM's document term matrix, the DTM or the topic models package, the latent semantic analysis LSA package. They have something called text matrix. We have a function called convert that goes to and from all of these. And there's this, the structural topic model uses this strange list that includes covariates, and we can export to that with no problem. It's much easier to do it in Quantita, export it, and do your analysis. A corpus is one of the core object classes. I'll walk you through these. These are corpus, tokens, and document feature matrix. A corpus is a repository for your text and all of the associated data. So once you put all of this cleaned up into your text, then you can put in your document variables and your meta variable. You have one nice tidy, I use that word, old school tidy object that contains everything you need, and from that you can get whatever you want. And it's quite easy to create. And it takes both document level variables and corpus level metadata. So here's an example constructing a corpus using a vector of text. It's a named vector of text because the names become the labels for your documents in the corpus. And what I've done here is I've just created this text vector called txt. I send that to corpus, and it creates a corpus that consists of 3 documents and 1 document variable. No, actually it does that here when I assigned a silly document variable as a data frame to it called day, A-A-B. I don't know what days those are, but if we use the summary command, then we get a sense of what the text contains, and we also get the document variables from it, plus some basic corpus level metadata. These are the corpus functions. So I mentioned that we have a very consistent grammar in terms of the naming scheme. You can see that here. The idea is that there's a shorthand corpus which constructs a corpus. Then there are a series of functions that start with corpus underscore. They always take a corpus in, modify it, output a corpus. So corpus comes in, corpus comes out, no exceptions. You can reshape a corpus, so you could reshape a corpus to paragraph units or sentence units. You could sample documents from a corpus. You can segment a corpus, which is very similar to reshape, actually. You can subset a corpus, which is like using the base R subset command, the same syntax. You can trim a corpus based on document length. Character functions we actually implemented to be completely consistent. Things that operate on basic text types use this same nomenclature. So if you want to uppercase or lowercase text types, that's a thin wrapper to the stringy conversion, which works on Unicode much more smartly than the base R conversion methods. And that's the same thing for word stem. So by encapsulating the word stemming, we are free to change the internals. We currently use the Snowball C package, but if we found a better one, we would change to that. Tokens. So the idea behind tokens is you have a simple command which constructs a tokens object. It's called tokens. You send it either a corpus or a character or a tokens, actually. All these objects take their own class in and modify them. You can set a series of options. These options are conservative by default. The only thing we remove by default is actually separators. And if you want to remove more, you have to do that yourself. I don't want to take responsibility for obliterating punctuation. You must do that yourself, for example. But this is slow, so when Patrick, this colleague of mine, he was visiting last week, actually. I shouted his name out earlier. He has this benchmark of speed. We really slow down here because we do a lot of special handling. You can turn that off and just go bare metal, white space splitting, and it's super fast, but we prefer to do this once, be smart, and handle it the way that you need to. Because unless you're doing a just-in-time application, you don't really care about whether it takes you 10 seconds to tokenize your giant corpus or whether it takes you 5. It won't take you much longer than that. These are the tokens functions. We have functions for creating engrams. We have functions for selecting. We have functions for removing. We can create word-stemmed version of tokens. We can use the tokens lookup. I'll give you a brief demonstration of that shortly. You can look up your tokens according to a dictionary to convert them into keys in a dictionary. You can compound them. You can take multi-word phrases and compound your words with underscores to treat them as single words. The Germans do this every day when they speak, but in English you have to do this manually. Document feature matrix. So a document feature matrix is a sparse matrix, a specially classed sparse matrix in the matrix package. These are all the functions for manipulating a document feature matrix. These parallel many of the operations in tokens. Why did we not just create a function called lookup and write methods for the different classes? We did that at first before we made a big revision of the API because this is more consistent. These are also object-oriented, but in a slightly less general way. This just makes it absolutely clear and gave us the chance to have a very consistent grammar. We also have a feature context matrix with many of the same functions, and this is very useful if you're doing embedding models. You can take you create a feature by feature matrix. You could do this with a window, and here I've actually assigned it weights. So these are weights that you can use. If you're doing a word-to-vec model, you need sort of a 1/n descending weight. Given the context window, this creates a very similar and very, very fast approach, and it's completely flexible. We have a variety of text models built in, including some that I've developed that are social sciencey. The classic ones are correspondence analysis and naive Bayes. Once you have your document feature matrix, you're free to use pretty much any machine learning algorithm that you choose, of course. We have methods like coefficients, like coef will extract the coefficients from these models. It's designed to be very similar. Predict is a method that works for these models. Just to show you, what I've taken here is the Pang and Lee movies data set, which 2,000 movies coded as negative or positive, movie reviews. You can create a corpus from this using a package that's too big to fit on crayons, so you have to get it from my GitHub account, but it's the 2,000 movies. And here what I've done is used a bit of piping to create a random subset of 500 movies that are positive, 500 movies that are negative. And I call this a movies training set. Notice the plus operator here. I've taken two different corpus objects and just concatenated them using the plus operator. Then what I've done is I've have this training data set. I've created a training data set by using document feature matrix. I've removed punctuation, I've removed stop words, and then I run the text model naive Bayes, which works just like the LM in sort of its syntax. The outcome variable is sentiment, and then I create a test document feature matrix, and basically once I fit this model and use the predict method, I get log posteriors and I get probabilities on a probability scale plus the predicted class. And if I do the confusion matrix down here at the bottom, which is in the faint lower left corner of the projector screen, you can see I didn't do too badly in terms of the prediction, and I didn't even tweak this. There are statistics for text. This is the sort of high-level functionality. You can score and identify multi-word expressions we call collocations. You can get distance functions. All of these are sparse. So they're fully sparse, they're fully efficient, and they won't blow up your screen if you have 5 billion cells in a document term matrix. There are measures for calculating keyness, which terms are mostly associated with a particular class or another class. There's lexical diversity, there's statistics for readability, and then there's the counterpart of distance, which is a similarity. So if you want to calculate cosine similarity across your documents, it's very easy to do and very fast. We also have some plots. Just to show you very quickly, this is a great exploratory tool, by the way. It's called Quick. We construct a quick object by giving it a search term. In this case, I looked for the word terror and all of the built-in data object of the inaugural speeches of US presidents. I get to see the context of terror. If I take the result of this object and use text plot for X-ray, which is down here, actually I'm going to do this for the word God. So how many US presidents use the word God? Well, if I take the result of that and I send that to text plot X-ray, then I get this lexical diversion plot. It's like X-ray because on your Kindle there's this graph thing called X-ray. And this shows you that they usually finish their speech by saying, God bless America, at least they have since 1961, but there are references throughout. There are other functions to do the number of things, like here's the number of letters in the Scrabble value of the letters in the word chaotic. I'm not sure why that's useful. There are great functions for dictionary analysis that I don't have time to show you, but one of the things, Julia, take note here, that if you basically take the tidy text sentiment, we created an as dictionary method to create our version, which is a named list for dictionary. Companion packages, there's a great package we've written called read text. You give it any set of files, any format, it reads them in and puts them into a data frame. Pretty much any format. useR is a package that will also do tagging of parts of speech and dependency relations and named entities. If you want to go for more, these slides will be available through the website of the conference. These are some links that I've put up. There's a great demonstration with Chinese and Japanese. I have two postdocs. One's Japanese, one's Chinese. Actually, I have two Japanese postdocs. And they're really interested in making this work with their languages, and it does pretty well. Thanks. I'm told we have time for one question. So now is when someone asks me, but can it do X? Yes?
So can it do very nice visualizations, like with colors, with different sizes, where it visualizes something really quickly and really nicely?
Can it do visualizations where you can do something really nicely with colors very quickly and very nicely? The answer is no. It can do it very quickly but not very nicely. But it's a ggplot object, so if you go back to the black and white thing here, define really nicely. Is that really nicely? It's basic, but it's a ggplot object, so you can add elements to it to give it the color once it comes back. So that's why we use the ggplot. It's great for this because the object comes back, you can dress it up. So yes, it can do nicely, but not quickly. You have to add a few elements yourself. Thanks.